Assalamualaikum. In this video, we will be presenting on our topic, which is application of differentiation. This video is presented by me, Nur Anisha binti Muhammad Azmi, and my partner, Nur Inshirah binti Luqman. So, what is application of differentiation? In simple way, we can understand that differentiation is the derivative, which is the instantaneous rate of a change of a function with respect to one of its variables, or differentiation is a process of finding the derivative or rate of change of a function. Differentiation and integration can help us solve many types of real-world problems. We use the derivative to determine the maximum and minimum values of particular function. For example, cost, strength, amount of material used in a building, profit, loss, etc. So now I will further expand on related rate. In differentiation calculus, related rate problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. In simple understanding, related rate is where things changes over time. For example, an ice cube in the shape of a cylinder is melting at a constant rate of 2 cm³ per second. Find the rate of change of the surface area of the ice cube when the radius is 4 cm. Given here is the height r plus 2 and a radius from the question 4 cm. Here I come up with the solution. First of all, we need to identify all the information given in the questions. We have dv over dt, negative 2, dA over dt, we need to find it, r 4, and height r plus 2. First of all, we need to make a formula to find dA over dt, which is dv over dt times dA over dv. In order to find dA over dv, we need to come up with another formula, which is dA over dr times dr over dv. By using the formula area, substitute the height r plus 2, and then we differentiate, and we got dA over dr. And then using volume formula and substituting the h r plus 2, and then we differentiate it, and we get dv over dr. Both of these value will be substituted in the previous formula, and then we can have dA over dv. And the last step, which is we using dA over dt formula that we make in the first place by substituting the dv over dt given in the question, negative 2, and dA over dv that we found earlier. And the final answer is negative 9 over 8, or negative 1.125 cm² per second. So now is the past year questions, June 19, question 3C. A spherical balloon is deflated at rate of 12 cm³ per second. Find the rate of change of the surface area when the volume is 36 pi cm³. Given here is the volume and area of sphere. So here I come up with the solution. First of all, we need to identify all the information given in the questions. We have dv over dt equals to negative 12, and then dA over dt, we need to find it, and volume 36 pi. First of all, we need to make a formula to find dA over dt by multiply dv over dt times dA over dv. In order to find dA over dv, we need to make another formula, okay, which is dA over dr times dr over dv. Okay, we use the volume to find the r. We get 3 and use the area, differentiate it, and we have dA over dr. And then using the volume formula, differentiate the formula, and we get dV over dr. Both of this value we substitute into the formula earlier to find the dA over dV. And the last step, we're using the first formula that we made to find dA over dt. But substitute the dV over dt given in the question, -12, because the balloon is deflated, and using dA over dV that we got earlier to over r, and the final answer, which is -8 centimeter squared per second. Next will be Inshira presenting her subtopic, the mean value theorem.
Next, we're going to learn about Rolle's theorem, mean value theorem. It is important for you to remember this formula. Now, let's look at the example. Given that function of x is equal to x squared minus 6x plus 8 and the interval is 2 and 5. The value of c must be in between this interval. The first step is to find the f prime x. So in this example, the f prime x is equal to 2x minus 6. The second step is you need to apply this formula. This is how you get the answer for the formula that was given. Hence, the function of 5 is equal to 3 and the function of 2 is equal to 0. So we substitute 3 minus 0 over 3 is equal to 3 over 3, and we will end up with 1. So hence f prime c is equal to 1. Hence, in order to get the value of c, you need to 2x minus 6 equal to 1, and you change the x to c. So it will be 2c minus 6 equal to 1, 2c equal to 1 plus 6, and 2c equal to 7. Hence, you will get c equal to 7 over 2 or 3.5. And then lastly, the c is equal to 7 over 2 is in the range of the closed interval of 2 and 5. Now, let's look at the example of past year question. It was given the function of x is equal to x plus 1 over x, and interval value is 1 over 2 and 2. First, you need to find the f prime x. In this question, f prime x is equal to -1 over x squared. You can get the f prime x by using the rule that was shown in the example. Next, you need to identify which one is A and which one is B. In this question, 1 over 2 is A and 2 is B. Hence, substitute in the formula that were given. In order to find the f prime c, you need to find the function of A and the function of B. Just substitute the value of A and B inside the first function that were given. Hence, f2 minus with f1 over 2 minus 1 over 2, you will get 3 over 2 minus 3 over 3 over 2. And there you have f prime c, which equal to -1. Next, -1 over x squared from the f prime x is equal to -1. Change the x to c and you will get -1 over c squared equal to -1. And the answer is c equal to 1. The conclusion of the Rolle theorem is that if the curve is continuous between 2 points x equal to a and x equal to b, a tangent can be drawn at each and every point between x equal to a and x equal to b, and functional values at x equal to a and x equal to b are equal. Then there must be at least one point between the 2 points of a and b. In the question, the c are the points that occur between points a and b. That's all from this subtopic.